which brings me to my next Jupyter notebook, conditional statements, looping, and comprehension. Some of the most important concepts in Python. And conditional statements and loopings are the most important concepts in any programming language. Okay. So conditional statements are just Boolean true or false checks for things to occur. In Python, the if-else statement is the simplest conditional statement. So what's going on here? I assign a variable to be 10, y to be 4. I print them out because I want to look at them or format them for you to look at. And then underneath that, we see our first case of white space occurring. Now, this if statement is a conditional statement. This is the condition that we're checking to be true. And then this colon means that we're entering into what's called a code block. A block of code that will be executed if this statement is satisfied. And then, moreover, to let the Python interpreter know that we're inside of this code block, we have 4 white spaces right here. Anything underneath this that is indented by 4 white spaces, or a tab for some people, anything that is successfully in that structure will be considered in that code block. Okay. As soon as we exit out of the 4 white spaces, we're no longer in that code block. In fact, now we're in the else part of this if else. So if this doesn't occur, we immediately jump to whatever is here in this code block. So if we run this, we should get the print statement what? X is greater than Y, right? Because X is 10 and Y is 4. Okay. If instead we make Y equal to 20, this statement won't be false, and it will immediately default to whatever is in this code block here. So now we should get the print statement X is less than Y. Now, what about if they equal each other, right? Currently, if this was a 10 right here, it prints out X is less than Y, but they're equal. It's not true, right? So we need to add an additional component to our conditional statement, which is the if else statement. So what this is doing is saying, okay, if this is true, execute this code block. Elif, else if, in other words, this is true, execute this code block. And then finally, if none of those occur, execute whatever is here. And you can have as many elif statements as you want, back to back to back to back, so long as you end it with the else. Okay. All right, so let's just copy this now and see what happens. Run it. And we see now we get the equals there. All right, next up we have looping. Looping is an iterative process that is used in pretty much every important programming task that you'll do. And they come in 2 flavors, or looping comes in 2 flavors, with a while loop and a for loop. We're going to begin with the while loop. So a while loop starts with the while statement and then some condition. So as long as this condition is true, whatever that condition is, this code block is going to execute. Notice the 4 white spaces for both lines. Right? Also, we have the plus equals operator here, which is incrementing this variable by 1 each time this code block executes. So what happens is this runs, and then this condition is checked, goes down again, checks the condition again, so forth and so on. So let's go ahead and run this. All right, so notice it did exactly as should be expected. I is equal to 1, so this condition is true, right? 1 is less than 10. So we enter into the code block, we print out I is equal to 1 here, and then we increment I by 1. And then we check this again, which happens to be true. print I again, so forth and so on. If I change this to be like 15, there. If we wanted to be inclusive, we do less than or equal to be inclusive. Okay. Now, next up, for loops. So for loops are encountered typically when you're searching through some object that is iterable. Okay, and we'll learn about iterable objects later, but for now, you can just think of objects that you can index through. That's not what iterable objects are, but for now, that's all we know about. So this is a list of names, which means we can index through it. So we can get each name out of here with the for loop. So what are we going to do? For name, where does name come from? In this thing called names. For each of those things that are in there, print it. So what it's doing is it's looking inside of this, it's grabbing that, printing it, grabbing that, printing it, grabbing the next one. It's going to print each thing inside of there. So if we run that, oh, I need to define names. Just prints everything out. Now, for those of you that might have experienced some C++ programming or C programming in the past, you might be wondering about what the indices are, the place values for each of these variables in that list. Well, the cleanest way to get those index values is with the built-in Python function enumerate. Enumerate is going to generate a list of tuples with length equal to whatever you're enumerating through. And what do the lists consist of? The first, not list, yeah, so it's a list of tuples. So what do the tuples consist of? The first entry in the tuple is the index value for this variable in the list. Okay, so hopefully this print statement is clear, because where are I coming from? I, comma, name come from enumerate. I is the index. The thing that prints out as name is the value in there. All right, so if we copy that and run it, we see that at index 0, this is the value Randy. At index 1, the value is Andrew, so forth and so on. So you can clearly see which index points to what position in that list. Another common task. So by the way, data science, I use this all the time in my data science programming. Enumerate is very common. For loops are common in general, but enumerate I use all the time because I'm curious about the index of a given row of data in a matrix. Next up, another common task is pairing data together from two separate lists, right? Like notice that these have the same length, right? And I want to pair them together. We can do this with the built-in zip function. Again, very common function to encounter. So zip makes tuples from these two lists, or actually 3 lists or 4 lists, how many lists you want to pass in there. It makes tuples with the each tuple has the same number of entries as however many lists you pass in it. And I think it's pretty self-explanatory here. Where does name come from? It comes from names. Where does age come from? It comes from ages, and they're paired up with each other. So we should expect Randy to be paired with 34, Andrew to be paired with 35, so forth and so on. Yeah.
So are they paired by their indexes?
Yes.
Okay.
And if you wanted to know more, as we did before, add a new cell, help, zip. And you'll get all the description that you want to about that function. Don't forget about help. Python is one of the best documented programming language that there is, right? The documentation is incredible. So always make use of the help function when possible. And then also don't forget Google. All right, so next up is comprehension, another very important topic. Now, for those of you that don't come from a Python or Julia background, comprehension might seem strange. But if you know what set builder notation is, it's very simple. So set builder notation in mathematics is what belongs in the set. You have something such that some condition is valid, is true, right? So this is building a normal list of values between 1 and 10. What if we wanted to build even values? We wanted to get all even values from here, right? So what goes in this list? This is what goes in there, x. Where does x come from? 4x in normal list. So x comes from there, but it has to satisfy this condition. This is the modulus operator. X divided by 2, remainder is 0, meaning it's even, right? So all the things that will be in here will be every x in this list such that when divided by 2, there is no remainder. For odd, it's everything in that list such that when you divide by 2, the remainder is non-zero. So this is the not equals operator. Okay. We can also do this with dictionaries. For example, what goes in this dictionary? Well, x value, right? So key value, if x mod 2, or remainder when divided by 2 is 0. Otherwise, the key value is odd, right? So x, and then this entry here depends on whether or not the remainder is 0 or 1. And where does x come from? That list. Okay. It's one of the most common ways to populate a list or dictionary or tuple that you'll see. And you'll see that it works. Key value, everything's nice here. Okay, so that's part